Hi, my name is Isabel Bermudez. I'm currently a master's student at University of Wisconsin's Madison School of Pharmacy studying psychoactive pharmaceutical investigation. And I'm really stoked to be a part of IPN and to be presenting in PsychedelX this year. And my talk today is titled An Epidemic Opportunity, TBI-induced working memory deficits as a proof of concept model for psychedelic-assisted therapy. So to begin with, I'll start with how I got here talking about traumatic brain injury in the first place. Personal experience. My path here didn't start on the lab, it started on the softball field. I studied cognitive neuroscience in undergrad at Carnegie Mellon University, but what actually brought me there was softball. I played on the varsity team. And throughout my career, I sustained several concussions, pretty similarly to the guy on the bottom left there. Used my helmet instead of my glove. And these experiences are what pushed me to study how concussions impact working memory, and ultimately what led me to psychedelics. So what is TBI? TBI isn't just a bump on the head. It sets off a cascade of physical and functional changes in the brain, beginning with the primary injury, which is the initial force of contact. When the head makes contact with whatever is causing the injury, the brain moves around within the skull. It's about the texture of jello. And so when the brain shifts within the skull, brain meets bone and brain loses. So as the brain is trying to heal itself after this knock, this jolt, this hit, it's tired, it's inflamed. And if you continue to use it, the brain becomes overworked and leads to long-term functional and structural changes. If you got shoved into the ground, you wouldn't feel great as soon as you got up. But if you got shoved all the time, you're going to have some longer-term functional and structural problems. But anyways, TBI is also a silent global epidemic. It's a $400 billion global public health burden every year, and there's 55 million new cases annually. That's the same amount of people that would be involved if 148 Boeing 747 jet planes crashed every single day, or if the entire population of the country of Spain got a concussion. So left untreated, these injuries can lead to long-term inflammation, degeneration, and cognitive issues. So it's important that we're focusing on them. The systems that take the hit first are attention and working memory, two cognitive processes that shape how we interact with the world. Now, this is a diagram of working memory on the left. All of the information that we get from the world has to be filtered. We get more visual information in 1 second than the Hubble Space Telescope has ever gotten in its entire lifetime. All of that has to be taken in, processed, and used efficiently so that we can actually interact with the world. So all of this information gets filtered through selective attention and ends up in working memory, which is what's right in front of us at all times. Working memory allows us to maintain task representations, to keep phone numbers in our head, to remember what turn we have to take next when we're driving to the grocery store. Working memory is if you didn't have it in front of you, you'd be in a coma. And so when working memory in this filter plays out in real life, you could look at an example of a cocktail party. At a party, you have music pumping in from the ceiling. You have other conversations in the background. It's noisy. And you have to be able to filter out all of that external noise to be able to focus on the conversation that's with your partner. And the only things that are really in front of you in that working memory pot, this cauldron of concept formation, are the things that are relevant. So this filter continues to be updated as we move through the world. But this filter in this process is affected by traumatic brain injury. As this filter no longer works, the working memory becomes jumbled. It's inefficient. And on a impersonal scale, the individual isn't able to pay attention to the conversation, isn't really able to focus on the music, isn't really able to focus on the environment because they're all overstimulating. This is reflected in the symptoms that people with TBI experience, like light sensitivity, noise sensitivity. These things can't get filtered out like they're normally supposed to be. And so it leads to a system overload. And this is further reflected in brain scans by lower thalamus volume. The thalamus is what's responsible for the sensory gating. And people with a history of repetitive head impact, of repetitive head trauma, have lower thalamus volumes. And so everything is noise. And we're not guessing here. There are tools that we can use online to assess working memory and other attention symptoms, like, for example, the impact test. This is an FDA-approved class 2 medical device. It's been administered over 25 million times. And it can be used as a standalone test to identify athletes even intending to hide their symptoms of injury. And so I'll give you a little bit of a walkthrough how it works. I've taken it my fair share of times. The impact test is administered as a baseline test to almost every high school, college, and professional athlete in the country. I've taken it probably 6 times before I even got injured. Um, and so it's a massive, massive database of all of these measures that are looking at working memory and whatnot. So I'll walk you through how the test works. First, you would give a little bit of a symptom report. You would be asked to memorize words. They'll flash you with a bunch of separate words. And you're expected to hold them in, and it'll show you a bunch of abstract shapes and ask you to remember them. And then it'll go on a separate note and have you do tasks like this one, which is a symbol matching task, where you have to remember which symbol matches which number. And then they'll present you with the symbols and the numbers. Same deal, where you're maintaining this information, maintaining this task, and you're expected to respond to it. And so after you do these other tasks like symbol matching, then you're asked about the words again. You had to keep those in while you were doing all of these other processes. Same thing with the symbols, right? And so through these kind of tests, you can look at how the brain is able to maintain and use and filter information to be effective in the day-to-day world. And so another task that's used to assess working memory is the NBAC task. In this task, the participant is presented with a sequence of stimuli, in this case, letters, and asked to decide whether the stimulus matches the one n steps behind. So for example, you're seeing an H. If it was a one-back test, I would have to say if there was an H immediately afterwards. Or if it was a two-back test, it would have to be the letter two back before, would have had to be an H. So anyways, we have ways to measure this, and now we need new ways to treat it. But why am I talking about TBI at a psychedelics conference? Psychedelics represent a transformative treatment opportunity for working memory deficits caused by TBI. But also, working memory deficits from TBI could offer a powerful proof of concept model for psychedelic-assisted therapy. So first, we're going to go into the treatment opportunity. Psychedelics are catalysts for cognitive change. They may be able to reopen critical periods, which are temporary windows of enhanced neuroplasticity in which the brain is extremely malleable by experience. And it does this through neuroplasticity, which is the brain's ability to grow and reorganize neural connections. And psychedelics can enhance our ability to do so, increasing the flexibility with which we move through different ideas and concepts, and increasing the connectivity of different parts of our brain that don't normally talk to each other. And psychedelics, this is a graphic on the right of on top, it's going to be the acute subjective effects of different psychedelics, including ketamine, psilocybin, which is the active ingredient in magic mushrooms, MDMA, LSD, and ibogaine. On top, it's their acute effects and the length of time that the actual experience, the trip, the dose lasts. And then on the bottom is the critical periods. The reopening of these critical periods, these potent, malleable states of where the individual is able to learn, are open for weeks at a time. It's a prolonged period in which recovery is possible with the right intervention. Normally, these windows close when we're a kid, right? Critical periods are, for example, the reason why it's easier to learn language as a kid, because before the age of 7, the brain is much more plastic and it's able to take in that information from the environment. But after age 7, it's a lot harder because the brain is much more crystallized. Psychedelics can change that process and reopen our brain's ability to learn that efficiently. And so ultimately, experience is required for this learning within a critical period, which is why it's not just psychedelics that are the therapy, it's psychedelics plus therapy producing the positive outcomes. This makes psychedelics powerful catalysts for recovery. And so how does working memory fit into all of this with psychedelics? Well, working memory or psychedelics can actually open that filter in the brain to let more things through than would normally get let through. We always talk about how psychedelics can open your mind to new possibilities, but we're thinking about that in a really abstract sense. But what about in perhaps a more literal sense, right? If you're in this kind of cocktail party, your brain is now open to paying attention to different things than you may normally pay attention to. You may be accidentally catching on to the music. You may be catching on to the door. You may be catching on to the people around you. It may be harder for you to focus on the conversation with the person next to you, but your brain is open to catching new objects in the environment. And because there's new objects that are entering this cauldron of concept formation, new concepts are able to form. So that, in turn, leads to learning and long-term memory. And then working memory also has the capacity, the ability to pull from long-term memory as needed with the context within the goal. And so all of these things are important in the way that working memory and psychedelics work, right? And so acutely, psychedelics cause a decrease in the working memory and processing speed ability on tasks. But post-dose, there's an increase in working memory and process speed. Why is that? Well, we can see that psychedelics in the acute experience are able to affect this system. They're reopening what one is even able to pay attention to. They're opening this process up. But that means it's a therapeutic target. If these systems are the ones that are affected acutely, that means that the drug is acting on the system. So that means the critical periods may also be within those systems as well. And so if you were to, for example, pair that with therapy, which we're going to talk about a little bit later, you could have really positive outcomes. And so there was one observational study of veterans with a history of TBI that went to Mexico to seek treatment with ibogaine, psychedelic, and they saw persistent increases in working memory and processing speed, as you can see on the right. Yeah. And so TBI pathology and psychedelic action. TBI creates a long-term problem, like I was saying before, inflammation, cognitive inflexibility. The brain isn't working efficiently. There's impaired connectivity. Giving that drug to the individual with that concussion will increase that functional connectivity, that cognitive flexibility, the ability of the brain to talk to each other, talk to itself, and reduce that inflammation. And so even in the absence of therapy or experience, the individuals are still going to see an improvement. The people here, the veterans with TBI, did not have therapy involved necessarily in this in the way that we're going to talk about later, but they did with the substance. That inflammation the reductions in inflammation slows the progression of the disorder, while the increased functional connectivity, cognitive flexibility, neuroplasticity allow the individual to heal. And some companies are looking at this in terms of clinical trials. There's two companies, Gilgamesh and Sonera, who are looking at ibogaine to treat TBI. But in the context of the broader psychedelic field, it's a systemic blind spot. Despite established potential to treat traumatic brain injury, the field is almost exclusively focused on psychiatric indications. TBI outcomes, like the ones on the impact test or the NBAC test, are quantifiable, tangible, and measurable, unlike self-reports from patients and other psychiatric disorders. And these tests are via an FDA-approved medical device. The psychedelic field is struggling for FDA approval. The FDA, some members of the board weren't even aware that therapy was a part of the protocol with psychedelic-assisted therapy when, in August, Lykos's application for MDMA to treat PTSD was rejected. An FDA-approved medical device for the assessment of outcomes in this indication is a big deal. This is also a $400 billion global public health burden with literally no available treatments. This is a huge opportunity. There's literally no excuse for the field to continue neglecting this indication. None. It's unacceptable. And so that brings me back to why I'm talking about TBI at the Psychedelic Conference, because it is a transformative treatment opportunity, but it's even more than that. Working memory deficits could offer a proof of concept for psychedelic-assisted therapy as a whole. And now we're going to get into that. So what would rehab or therapy for working memory or TBI look like? This I found out the hard way. When I got my most recent concussion, I finally saw a specialist. And when I was there, they tested my cognitive deficits. I took the impact test. You can see some of the words highlighted there. And they were able to find my specific cognitive deficits and then design a rehab program around them. And so with a deficit-directed treatment plan, the goal of my entire therapy process with this office was to capitalize on the natural period of increased neuroplasticity post-injury. So when you get a concussion, there's a very brief period in which the brain is slightly more plastic than usual, and then it can heal itself. But which is why, if it's not used effectively, it can lead to long-term detriments. But with therapy can lead to long-term positive outcomes. So this therapy was taking advantage of that. The goals of the rehab were to reduce inflammation, to improve cognitive flexibility, to promote plasticity. Sound familiar? I was like, ding, 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 psychedelics have the potential to augment this care. And so I want to challenge the audience to expand their definition of what they think psychedelic-assisted therapy could be. Oops. To be metaplastogen augmented cognitive rehabilitation. What are metaplastogens? Metaplastogens are psychedelics are metaplastogens. Metaplastogens are substances that increase the brain's plasticity for plasticity. They increase the brain's capacity for change, but that still requires experience. That still requires learning and structure. And so that's why metaplastogen augmented cognitive rehabilitation, though a much longer and less savory sentence off the tongue than psychedelic-assisted therapy, could be the future of what psychedelic-assisted therapy is. And so in this, you would be capitalizing on critical periods, right? We saw that critical period graphic from Gould-Dolan's lab a few slides ago, right? So after the dose, the critical period reopens. That leaves us with a really fertile therapeutic window. And timing is everything. So when the brain is primed to change, what we do with that window matters, right? And so that's where structured rehab, deficit-specific therapy, like what I did, becomes so valuable. You may see some benefit just with the dose, but you're not maximizing the potential of what we could get from these substances. So like I was saying, critical period plus experience equals learning. And as a transdiagnostic target, working memory has applications far-reaching outside of TBI. Working memory deficits show up across mental health diagnoses, including substance use disorder, where if we're back at our cocktail party, this individual is biased towards salient cues if they were an alcoholic, the music, the alcohol, these are triggers. They're more able to invade that working memory cauldron. Those signals are no longer, not suppressed in the same way that they would be without the substance use disorder. Similarly with PTSD, this individual noticed the bottles, noticed a gun on somebody's hip, was hypervigilant, noticed that the doors were closed, always on alert. The system is filtering things differently for this specific goal of keep me safe, which then in turn leads to deficits on working memory tasks because these resources are limited, right? Similarly with OCD, compulsive checking behavior. This has been associated with working memory as forgetting is an important component of compulsive checking behavior. Forgetting if you had checked the stove, forgetting if you had washed your hands, forgetting if you had done XYZ. Working memory is implicated in far, far more than just TBI. And so if we can move the needle on working memory, we may be able to impact many conditions, including anorexia, major depressive disorder, generalized anxiety disorder, ADHD. There's more than just TBI here. This is an important topic that we need to be studying. And so that brings me to this. Working memory and TBI can bridge a psychedelic-assisted therapy gap. We have one camp where, so we have psychedelic-assisted therapy, right? Traditional psychedelic-assisted therapy, quote unquote. Cognitive therapy for cognitive outcomes, focusing on things like treatment-resistant depression, PTSD, OCD. But then we also are seeing a newer wave of neuroplasticity-based treatments, like treatments for stroke recovery, for limb recovery after injuries such as that, which would be physical therapy for physical outcomes, right? Using neuroplasticity to rebuild these physical functions. But in the middle, that's where we could bring in metaplastogen augmented cognitive rehabilitation, which would be physical therapy for cognitive outcomes, using that working memory to bridge the gap between the mind and the body camps. And if psychedelics can help restore working memory and recalibrate attention, it can help us understand why they work across so many different conditions. They can bridge the gap between neurobiological mechanisms and psychological change. And it can actually help us understand what therapy is doing during these altered states. The work is just beginning, but it's where I believe the field needs to go. So thank you for your time. If the study resonates with you, let's talk. Please reach out. I'm in the market for a PhD program.